Good morning, good afternoon, or good evening. This is going to be a full paper work through of the practice set of Further Maths Level 2. As always with these papers, I've looked through them, but I haven't prepared anything, so I'm hoping to give the best first impressions, the best thought processes as I go through this paper. Mostly so you can see what kind of thoughts are most helpful in tackling a paper of this level. This is paper 2, so I have my calculator ready and waiting to help me through this paper. Straight in we go. Question 1. 4 sketches. Circle the letter of the sketch that represents that. Well, we notice we have a negative power up here, so this is representing a version of decay. That 3 also tells us we start at 3 on the y-axis. So I'm looking for one of these graphs which starts at 3 and looks like a decay. Well, that is B. Alternatively, a really good way to deal with this question is just to do a quick table of values and test some values. If I tested, let's say, -2, 0, and 2, at 0 I get 3, at 2 I get 3/4, and at -2 I would have got 12. Of course, you check those in your calculator, and that's showing exactly the type of decay that B is showing. So if in doubt, if you have forgotten what these graphs look like, doing a quick table of values, just checking a few values can be exceptionally helpful. Question 2, a circle has that radius and that centre. Now, remembering that our circle formula is x minus the x coordinate, so it can't be that, it can't be that. Y minus the y coordinate, so that has to be a plus, which both of those, or those two don't work, but the two uncrossed out ones still do, equals the radius squared. Well, that one has the radius squared, the other one had the square root of the radius. X and y are integers. Between, well, x could be -8, -7, -6, -5. Y could be 0, 1, 2, 3. We need to say whether the following are always or sometimes true. So if I take any x value and I multiply by any y value, is that always less than 0? Well, no, because if I choose y to be 0, xy will equal 0. So it can't always be true, but any other combination, -8 times 1, for example, is negative. Is x squared always bigger than y squared? If I take any of those x values, is that bigger than any of the y values? Well, yes. Squaring gets rid of the negativeness, and the x things are just bigger in absolute size. So that's always true. Question 4. A matrix multiplication. Work out the value of A. Well, I'm going to start just by taking that left-hand side and expanding it out fully. Then I'll worry about what else I can do. Remembering that matrix multiplication, we do row times column. So the top there comes out as -12 plus 0b. Don't care about 0b. And then 2b times 4 plus b times b. And that is equal to the right-hand side to a 20. In part A of the question, we've only been asked to find the value of A, which we get from just comparing the top curve, the top components. So A is -6. B, we compare the bottom components. And what's nice here, it does say 2 possible values, and I've got a quadratic here. I know quadratics often have 2 separate values, and I know for quadratics I need to rearrange it to make it equal to 0, either factorize or put it into the formula. This one, 20 comes from 2 and 10. A -2 and a +10 makes the 8 in the middle, so therefore from our 2 brackets b equals -10 or 2. They're my 2 values of b. Question 5. This could have come off, well, no, not quite. I was going to say this could have come off a GCSE question, but it's a little more challenging. It doesn't have any new material on it, however. I'm going to work out both sides separately so I can compare them. The left hand side, I've got 2 to the power of 6. 2 to the power of 6 is 2 times 2 is 4, 8, 16, 32, 64. And then m to the power of 30, multiply the powers there. The right hand side, well, I can't do anything else other than just write a cubed and multiply the powers gives me 3b. So I have two things to compare here. A cubed has to match that 64, which means a is 4, and the 3b power has to match the power from before, creating b is 10. So my answer, a equals 4, b equals 10. B, very similar again. I'm going to again deal with that left hand side as much as possible. Now I do have the calculator this time, so I can do the 49 plus 28 from adding the powers on the numerator to get n to the 77 over n to the t. Well, then I've got a division, which is a subtraction, 77 minus t. And then the square root, we need to remember, is to the power of a half. Then I've got a power to a power, so my power here is 77 minus t all over 2. And we know that that is equal to n to negative 4t. So 77 minus t over 2 equals negative 4t. Simplifying that, I'm going to multiply up by 2 first. I don't like having fractions if I can help it. Add on a t. I'm particularly happy because there's so many 7s about, and t comes out as negative 11. Question 6. Y equals that thing, and we want to work out an expression for the rate of change of y with respect to x. Well, that whole statement there is just a very, very posh way of saying find dy by dx, or the derivative. Now, in its current form, I cannot find the derivative. I need to expand it out so it's just powers of x. So I'm going to do that. I'm going to deal with the squared bracket first, remembering it is a double bracket. So I need to remember to get the outside and the insides in there with the 4 to get the 4x at the end, and then finally expand out with that. I'm going to simplify as I go. I get a plus 1 x squared plus 4x squared, so it's plus 5x squared. I get a plus 4x and a plus 4x in those two combinations, and finally a plus 4 on the end. Because you show more working as much as is sensible for yourselves. Now differentiating, bring down the power, reduce the power by 1. Bring down the power, reduce the power by 1. The 8x we recognise just turns into 8 and the 4 disappears. So the derivative of that curve is 3x squared plus 10x plus 8. Question 7. The 50th term and the 65th term are given by those. The kth term is the first one greater than 1,000. Well, this feels immediately from these two statements of simultaneous equations. So let's use those two statements. So the 50th term, we remember our formula a plus n minus 1d is 327. U65 is a plus 64d is 432. Well, now I can find the difference if I do, I want to do equation 2 subtract equation 1 to keep things a little bit positive. The 64 minus 49, and then the other side is 15d equals 105. So d is 105 divided by 15, which is just 7. And then a, I can work out from either of the others. I'm going to use the top one, 327, subtract off 49, lots of that value. A comes out as negative 16. Was I expecting negative? Maybe. I am going to check in U65 very quickly. So negative 16 plus 64 times 7 does indeed come out as 432 as required. So now I know everything I can possibly know about this sequence. I know A and D. The kth term is the first term greater than 1,000. That's saying UK is greater than 1,000. So let's try and solve that resultant inequality. So that's A plus K minus 1D is greater than 1,000. Just solve this inequality nice and fast. Add on the 16, divide by the 7. This is where we're likely to get some kind of decimal. Indeed we do. I'm going to leave it as in decimal form. Therefore K is greater than, add 1 to that, 146.1. So the kth term is the first term greater than 1,000. K has to be bigger than 146. So the first time K is bigger than 146.1 is at 147. A nice way to check for this question is if I type in to find the kth term, so that's negative 16 plus 7 lots of 147 minus 1, I get 1,006. And if I take one step backwards, so using K to be, or N to be 146, I get 999. So indeed, we have confirmed that the 147th term is the first one bigger than 1,000. Question 8. We have two lines, A, B and C, D intersect at M. M is the midpoint of AB. Well, that'll tell us exactly what the coordinates of M are. And we've been told some ratio between CM and MD, and we want to find C. Okay, well, let's use that first thing we noticed first, that M is a midpoint. So M is going to be the average X coordinate of A and B and the average Y coordinate of A and B. That'll be 5, 4. We have here that this here is 5, 4. Well, now we need to try and use that ratio. We've been told that this bit here is twice as long as that bit there. Well, actually, there's quite a sneaky way of doing this just by thinking about what the changes are. Well, here we changed in the X by 3 and the Y by 1. Well, if I do exactly the same over here, well, this part is twice as big as MD. So if that was a 3 and 1 change, then this has to be a 6 and 2 change. Well, then that's clear what C will have to be then. So C has taken 6 steps back in the X, so that gets us to -1. It's taken 2 steps down from 4 to get us to 2. Nice way of visually seeing that ratio in action. Question 9. Factorise fully. Now, it might be tempting to try and expand out brackets first, to use Pascal's triangle and expand these powers out. You'll end up with a power 5 style polynomial, which you need to try and factorise again. That's just incredibly unpleasant. Instead, let's do what we normally do when we see factorise and think about what's in common. To the numbers, both of the numbers have a factor of 3. And both terms have this bracket many times, and actually they both have this bracket 4 times. The second one has it 5, but it has at least 4 of them. So what's left over if I were to factorise out that thing? Well, for the first term I needed to get 9 lots of the bracket to the 4. I already had 3 lots of the bracket to the 4, so I need an extra factor of 3. The second term, well, the numbers, I need an extra 2, but I need an extra bracket because I have factorised x minus 2 to the power of 4, but I want x minus 2 to the power of 5, so I need another copy of that bracket. Well, let's simplify my square bracket and see where that gets us. Well, I've got 3 plus 2x minus 10, so that's 3 lots of x minus 2 to the 4, 2x minus 7. Double check that nothing more can be factorised. There's no common factor in the x minus 2, there's no common factor in the 2x minus 7, so we are done. Sneaky question, surprisingly simple once you've got the idea that you can actually just factorise out an entire bracket. Part B of the question is another it doesn't say factorize, but we see the word simplify, we see a fraction, we know we are factorizing. So let's factorize everything first. The numerator. The numerator seems to have a common factor of 2 and y to the 5. That leaves behind 4y plus 3. The denominator you should recognize as a difference of two squares. It's a square thing minus a square thing with no middle term. Well, the way we create them is with the square roots of the two parts, a plus in one bracket and minus in the other. So the 16y squared means we need a 4y and 4y, the 9 means we need a plus and a minus 3. And now one of our brackets is identical on the numerator and denominator, so we cross them out, we rewrite our answer, we check if there are any other common factors. It might look like there's a y in common, but the y is not in the 3, so it can't cancel a y. Might look like the 2 is in common, but there's no 2 in the y either. Nothing else can cancel because nothing else is common to every single separate part. And that question's done. 3 marks for basically just factorizing again. Question 10. Show that thing can be written in that form. Well, that form you should instantly recognize as complete the square. So we're going back into our memory banks and remembering how to complete the square. The 3 at the front is the problem. So at least the way I like to do this is I factorize that 3 out of the first 2 terms. I don't take the 3 out of the number on the end, because that number on the end always just sits at the end and only gets involved right at the end when we simplify. Okay, well now I've factored that out, I can now complete the square inside the bracket. So we have, as so, and we don't need the, we need to subtract all the 16, sorry. And then we just have the minus 1 at the end. You can expand out that square bracket to double check it does give what you want, and it does. Well, now let's deal with my big square brackets, because they're not in the answer. 3 times the bracket, but then I also need to do 3 times the end thing, which gives me a negative 16. And finally, simplify with that minus 1 that we've left on its own this whole time, and we get as so. Now, we just pick out the values. A was the thing in front, B is in the bracket, C was the thing on the end, remember, in the negative sign. A nice way to check these kind of questions is just to sub in a random value. Pick some value and see if it works in both cases. Now, I'm going to actually pick negative 4 as my value, because negative 4 kills that bracket squared, and then I'll just be left with negative 49. So if I put negative 4 into the very original quadratic all the way up there, I'll expect my answer to also be negative 49. And I've typed that in, my calculator's given me the answer negative 49. Negative 4 was a fairly random number. You can test other values if you want, but that's a high chance that you've got this question perfect if testing a random value does work. Question 11. We have 3 straight lines, L1, L2, which are horizontal and vertical. They intersect at the point 3, 2. Okay, so I've got a coordinate here, 3, 2. That tells me that my L1 line is the line y equals 2. Horizontal line going through a coordinate with 2. And similarly, L2 is my coordinate x equals 2. Sorry, x equals 3. A vertical line going through a coordinate with 3. Well, that automatically gives me some useful things. I know the x coordinate here is 3, and I know the y coordinate here is 2. Let's keep reading the question. So we've got our L1 and L2. L1 is parallel to the x-axis. Okay, I've already used that fact. And then I've used the fact that the right angle's there to say that L2 is parallel to the y. L3 has that equation. Well, that surely means I can just work out the coordinates, let's give them some names, B and C. So at coordinate B, the x coordinate is 3. That's 2 times negative 3 plus 16. I think that comes out as 10. And then at our C coordinate, this time our Y coordinate is 2. And we need to work out our X coordinate, subtract 16, divide by -2, that says that X equals 7. And that does seem reasonable to the picture as well. Okay, so now I have all my coordinates, and I want that angle X. I'm going to draw the triangle separately and put on only the useful things. Well, this now feels like find the angle. This is a find, this is use trig. So my opposite, well, how long is that side? Well, it's vertical, so it's only difference in the y, so that's got a side length of 8. That side is only difference in x's, because it's horizontal, that's a 4. So that's saying that tan of x, because I've got opposite and adjacent, is the opposite over the adjacent. So we're doing tan inverse of 8 over 4, tan inverse of 2, gives me my angle of 63.4, etc. It wanted it to 3 sig fig, so I'm going to give it to 3 sig fig. Of course, having the habit of writing out more first tells the examiner that you're not making a mistake here. That's question 11 done. Coordinate geometry into trig. Question 12. Use the factor theorem to show that that is a factor of that thing. Remember, the factor theorem says that something is a factor if and only if the corresponding answer is a root, makes the thing equal to 0. So here we have the root from that bracket is 5 over 2, or 2.5. So the factor theorem says if, when I sub in 2.5, I get 0, then that thing is a factor. So let's sub in the 2.5. 2 times, and now it's a calculator job. It is, I would say it is essential to at least have written down what I have there. Being a show that question, you can't just say, hey, it equals 0. Let's actually show it a little bit more explicitly. So we've got one of our marks. So now let's just write our little conclusion. Therefore, by the factor theorem, we have that x equals 2.5 is a root, implies that 2x minus 5 is a factor. And that's done. Hence, factorise fully. So we know one of the factors. We know one of the factors has to be 2x minus 5. The other factor, because this is a cubic, the other factor has to be a quadratic. So let's do exactly that. Well, how do I create a 2x cubed? To create a 2x cubed, I have the 2x, so I need an x squared to go with that 2x. How do I create the plus 9? Well, I have here minus 5, which means I need an extra 14. Well, 14 times 2x times something is going to make 14x squared. That's plus 7x. Of course, you re-expand these regularly just to check that you are getting the right thing. I've got my minus 5x squared plus 14x squared. It does give me my plus 9. I need to get, excuse me, I need to get minus 11x. Well, I have minus 35x here. That means I need to add on 24. So these two need to make a plus 24x, or 2x, that means that's a plus 12. And the final thing you can check is, does these two, do they make the number on the end? Do they make that minus 60? And indeed they do. So that's a good little check that you've at least got most of this correct. It said factorise fully, so let's try and factorise the quadratic term as well. Two numbers multiply to 12, add to 7, x plus 3, x plus 4, and that is factorised fully. Question 13. PQI is a right angle triangle with an area of A and A is less than 700. Okay, well the only thing I can do is try to work out this area, an expression for the area A. We know area of a triangle is base times height, and conveniently we have been given exactly the base and the height. And we've been told that that is less than 700. Well, actually, now I have a quadratic inequality. And we've very quickly converted from the geometry style question to a quadratic inequality. I'm going to multiply by 2 because I don't like having that half. I'm going to get 1400 on that side. And this side I'm going to expand out the brackets. I get my 9x squared. Got minus 30 and a minus 15, and then a minus 10 times minus 5. Well, this is a quadratic, so let's solve it as a quadratic. Let's move the 1400 over to make it compared to 0. Next thing you should always check is, can I divide by something to make my life simpler? Now you might not spot it immediately, but everything is a multiple of 9. 1350 divided by 9 gives you 150. Not the easiest of spots, but if you remember your divisibility rules, if you add up all the digits and the digit sum is divisible by 9, then the original number was also divisible by 9. Now, of course, you do have quadratic formula, etc., but if you can spot the factorization, it is often much quicker. 150 is 10 times 15. 10 times 15 does give me a 5 in the middle, so I can factorize as so, making sure the negative goes with the 15 to make the negative 5. Quadratic inequality, we now have our two critical values, our roots, at negative 10 and 15. Well, now we need to have a quick look at the graph. And we have our negative 10 and our 15 roots. We care about where the graph is below the axis, the x-axis. So this is saying negative 10 is less than x is less than 15. Now you might be tempted to put that as your final answer. You solve the quadratic. But as I've always said, as soon as you think you finished the question, reread it. Go back to the original and see if there are any other restrictions. In this case, there are. We can't have negative side lengths. So certainly when x is negative 10, both of our sides are negative, which we can't have. So we actually have two extra restrictions. We have the fact that this up here has to be bigger than 0. And if we think about what that means, we can solve that, add 10, divide by 3. It says x is bigger than 10/3. And similarly, that one has to be greater than 0. It says x is greater than, add the 5, divide by 3, 5/3. Well, actually, the 10/3 one is a more restrictive condition, which makes sense. 3x minus 10 gets more negative, so we actually have to have the fact that x is bigger than 10/3 in addition to what we already have. Well, then the lower boundary, if you think about it carefully, the lower boundary just becomes that 10/3, and there's my final answer. I can't have x going lower than that value, but it can go all the way up to 15 if required. Question 14. Solve the simultaneous equations. Do not use trial and improvement. I like that as a addition. These are our triple simultaneous equations. So we remember our method. We need to try and kill off one of the letters we need to kill it off in two different ways. And then we can use the resulting two equations in two unknowns to do our normal simultaneous equations method. I like to label up my equations so that whoever's reading my solution can work it out. And as I'm talking, I'm looking which letter is easiest to deny. A has a 3, 1 and 2 coefficients. B has 1, 2, 3 coefficients. They're not particularly nice, but I'll notice that all of the C's Well, I can use equation 2 to kill off 4c, and I can kill off 10c fairly easily. And you can choose which ones to do. I'm going to go with killing off the c's. So to kill off the c's from equation 1 and equation 2, if I double the second equation, I get my 4c, and I can kill off by just adding onto equation 1. So I'm going to do that. Equation 1 plus 2 lots of the second equation, a plus 2 lots of a. We have b plus 2 lots of negative 2b, negative 3b, negative 4 plus 2 lots of 2c cancels out. And then 7 plus 2 lots of 11, 7 plus 22, 29. I'm going to call that equation 4 for later. So you've killed c in one way. Let's kill c using equations 2 and 3. Now this one's a little bit less pleasant because I'm going to have to do a subtraction. So if I take equation 3 and I subtract 5 lots of equation 2, well, that's making my 10c to kill off. So let's just carefully do that. For the a's, 2a, subtract 5 lots of a, gets me to negative 3a. 3b, subtract off 5 lots of negative 2b, so I'm adding 10b, so that gives me 13b. The c's, 10c minus 5 lots of 2c cancel. The 4 minus 5 lots of 11, oh, I'm going to do that one in my calculator. 4 minus 5 lots of 11 comes out as negative 51. Not very pleasant numbers here at all. So I'm going to keep an eye on the numbers and hope that they don't get any worse. Well, now I have a normal set of simultaneous equations. Let's solve these. I need to try and match up one of the letters. I can either make the a's the same or the b's the same. The a's look like they're easier to make the same. So I'm going to times the top one by 3. I'm aiming for them all to have 15a. 29 times 3 comes out as 87. And times the bottom one by 5. Again, getting the 15 that I wanted. 13 times 5 is 1, 2... No, let's just do that in the calculator. It's just 65. Plus 65 there equals negative 255 from 51 times 5. I've lost the b on that term. And now adding these two equations, because the a's have the same number but opposite sign. We've got 65 add a negative 9, so that's 56b and 87. Now I'm really hoping that this is going to give me, what's this? I said 56, didn't I? 56b. I'm really hoping that this is a nice multiple, and when I do 168 divided by 56, I get a whole number. Indeed, I do at negative 3. So that's really pleasing. That's really important to see. Now I need to go back and find a. I'm going to put that into equation 4. So that's 5a, well now minus 3 times minus 3, so that's plus 9 equals 29. Oh, that's lovely. Subtract off the 9, divide through by the 5, I get 4. At this point, I can do one of my little checking techniques and have a look back into equation 5. Negative 3 times 4 plus 13 times negative 3 does give me negative 51 that I required, so at least I haven't done anything silly in this little section. But now I need to go back and find c. I can choose any of the equations. I'm going to choose equation 2. That seems to have the simplest c stuff. So that's saying 4 minus 2 lots of negative 3 plus 2c equals 11. 4 plus 6 is 10, subtract it off, 2c equals 1c equals a half. Okay, so I seem to have all my values. Before I actually write them on the outline, I am going to type them into my calculator for equation 1 and equation 3. Equation 1, 3 times 4, subtract 3, minus 4 times a half, hit equals, that is 7. 7 is what I wanted. For equation 3, 2 times 4, plus 3 times negative 3, so subtract 9 plus 10 times a half does give me 4 as I wanted. So I'm incredibly confident that these are my correct values, and I can write them down on the answer line and be happy. Question 15. Integers are made using some of those digits. It has 4 digits, is greater than 3000, has no digit repeated, and is a multiple of 5. Lots of conditions there. So we have 1, 2, 3, 4 gaps to fill. Now, I think the most restrictive condition here is actually the multiple of 5, and that will make a difference. So the thing I'm worried about is the greater than 3000 condition matters whether you've got your 0 at the end to be a multiple of 5 or the 5 at the end. So actually I think counting from the back of the number and separating by those two cases might be much smarter. So I can either have a 0 at the end or a 5 at the end. If I have a 0 at the end, well, that means I can start my number with 3, 4, or 5, which means I had 3 choices here. Well, then there's no more restrictions. I'll guarantee to be bigger than 3000. Now I just need to not have repeats. Well, I've already used at this point 2 of my digits, 3, 4, 5, and 0. So I've used 2 of them, which means there are 4 choices left. So I've got 4 choices here. I then used 3, and I've only got 3 choices left, and that one was fixed. So if there's a 0 on the end, it's 3 times 4 times 3. There are 36 ways to make a number bigger than 3000 with a 0 on the end. If there's a 5 on the end, our calculation has to be slightly different because there's only 3 or 4 as an option for slot 1. So that means there are only 2 choices for slot 1, but I still have 4 choices here and 3 choices here, and the 1 was fixed. The 5 at the end was fixed. 2 times 4 times 3 means there are 24 ways to make a number ending in 5 bigger than 3000. So therefore, there are 60 ways in total in those 2 choices. A little bit of restriction there. You could have actually done the things in the order that they're written, and restricted by having the 3 at the front, the 4 at the front, and the 5 at the front. And you would have got then 3 different situations for each of those, and some of them you'll be able to times by 2 at the end for the 0 or 5 at the end, and one of them you'll only be able to times by 1 for the final coordinate. It might be a good thought exercise to try and do it that way as well and confirm whether it gives the same answer. Question 16. A, B, C, and D are points on the circumference of the circle. We have that AB is equal to BC. So that's saying I've got an isosceles triangle ABC. We have that BC is in the ratio with CD. Okay. I'm not entirely sure why that's going to be relevant yet. Oh, I suppose it can find the length of BC immediately. Okay, well, one of the first problems that we have is we don't know this angle x. So I'm going to deal with that x first. We do have a cyclic quadrilateral though, which means that the opposite angles in that cyclic quad add up to 180. And I didn't say give reasons, but I'm going to write it down anyway. Those angles in a cyclic quad sum to 180. Well, that can find us our x. That's 5x equals 180. 180 divided by 5, so x is 36, 3x is 108 and 72. So we actually have those angles now. Now our actual aim was to find the angle, the area of the triangle ABC. Well, if I do know these 2 equal sides, then that's a half AB sine C fairly easily. So let's use that ratio statement then. So BC to CD was root 2 to 2 but we know that CD is 5 root 3. So if I divide, so here, if I divide by, I could write this in a different way. I'll write this as root 2 over 2 to 1 by dividing both sides by 1. And then I can just multiply by 5 root 3. And that would just work. So if I multiply both sides by 5 root 3, that gives me 5 root 6 over 2. So BC is 5 root 6 over 2. So I've just used that ratio. And if you do try and simplify that horrible looking ratio, it will get back down to root 2 to 2. Okay, so I have BC, which is the same as AB. So now let's work out our area. So our area equals a half BC times AB sine 3x. It was labelled in the picture. It was. So that's a half of 5 root 6 over 2 times 5 root 6 over 2 sine 108. We're lucky. Well, we're not lucky. It was by design, but conveniently it is a calculator paper. So I'm going to type that carefully into my calculator. I'm going to cheat a little by squaring the 5 root 6 over 2 rather than typing it in twice. And that's giving me an answer of 17.83, etc. It's a little concerning that it just said find the area and didn't tell you to round anything. This is all the more important why I've written it out in full. Now, I'm just thinking if there is any way I could have cheated, if any way I could have got a more exact answer. But sine 108 is not an exact one of the things we know. So it doesn't appear we can write it exactly. So I'm going to do my own rounding, but making sure that I have written my full answer for my calculator in some position. Question 16 is done. 17. 3D trick. We have a cuboid, AB and BC are 7, and we've got a height of 24. Work out the angle EBG. And in order to work that out, it appears I need to know a lot of other angles. And the concerning thing is EBG is not right-angled. But BG, it is isosceles, however. So BE is the same as BG. It should be fairly clear by the symmetry, the fact that it is a square-based cuboid. And EG is our odd one outside. It looks like I can just do some Pythagoras's then. So using, what is that, A, B, E, I have a height of 24, a side there of 7. So BE squared equals 7 squared plus 24 squared. Work that out, 7 squared plus 24 squared. And I'm recognizing this as one of the rarer Pythagorean triples, is a 7, 24, 25 triangle. So BE is 25 there, and therefore BG is also 25. EG. For EG, we're going to look at the base, which has sides of 7 and 7. Now this is not going to be a Pythagorean triple, it's not going to give whole numbers. But it's not too unpleasant if you do type it into your calculator. I don't know why I wrote a 9 there. It comes out as 7 root 2 if you're leaving it exactly, which is actually quite nice. That's a general fact. If you have an isosceles triangle, the longest side is root 2 multiplied by either of the shorter ones. Only works for isosceles though. Isosceles right-angled. So that bottom side is 7 root 2. And I'm leaving it at 7 root 2 rather than a decimal because I'm in the middle of my working. If I can leave it exact, I should. We want the angle EBG, which is up there, which I drew wrong the first time. EBG is up there. Well, how do I find an angle in a non-right angle triangle? It's actually going to be cosine rule. So let's use the cosine rule, but of course we're doing it backwards. I'm going to call this angle up here theta. So cos of theta, making sure we get it the right way round, is the b squared plus c squared minus a squared all over 2bc, where b and c are the sides next to it. That's 25 squared plus 25 squared minus 7 root 2 squared all over 2 times 25 times 25. Typing that into our calculator carefully. Gives me a concerning, oh, that's why I got a number bigger than 1 in my calculator, which we know we can't cos inverse. I just put a sign wrong in a position. This comes out as 576 over 625. So my angle is cos inverse of that. This is again going to give me a horrible decimal, and the question didn't tell me how to round. So again, I'm going to write several more decimal places than is reasonable. Then on my answer line, round to something sensible. Does it make sense that that angle is roughly 22 degrees? That seems quite small. But if I do calculate 7 root 2 as an actual number, this is very roughly 9.9. Well, yeah, that seems like it's going to be a very tall, very skinny isosceles triangle. And even just on the picture in the first case, the 24 centimeters height says that it should be quite a tall, skinny isosceles. So a relatively small angle does indeed seem fair. Question 18. N is a positive integer. Prove that that thing is an odd number. We need to first remember what an odd number is. An odd number looks like 2 times something plus 1. So my aim is, once I've rearranged and expanded and simplified this thing, that I can write it as 2 times something plus 1. Well, the only thing I can do is to expand this thing out and try and simplify. Remembering that is a double bracket, so I get the middle term of 6n and 6n. I expand the first one. The second one I'm going to leave in a bracket with the minus sign in front. I don't want to lose that minus sign. It's incredibly important for collecting the like terms afterwards, because we are subtracting off each and every single one of those terms. We had our 9n squared, subtract n squared. We had 12, subtract 4, and then 4, subtract 3. Well, actually, this couldn't be nicer. We can already see that we have 2 times, well, the first 2 terms look very even, and we're adding 1. Let's make it incredibly explicit, so let's factorize out just the 2 with the plus 1 on the end. Now, I know we could factorize more out of the first 2 terms, but we don't need to. For what we're trying to show, we don't need to. So let's have our final statement, which is an odd number for any integer n. And we're done. A huge amount of working space for what turned out to be incredibly clean, but because it was a proof question, you have to have that conclusion. You have to show your steps carefully. Question 19. We have sketches of a straight line 4x minus 9 and a cubic on our picture. The tangent to the curve at the point P, well, where is the point P? Is parallel. Okay, so we need to try and find the point P. And we've been told we're parallel to the 4x minus 9. So somewhere we can draw one of these parallel lines and will be a tangent to the curve. Now you can see my first 2 are clearly wrong, but that third one seems to be a legitimate solution. And if you do think about it carefully for a while, you'll notice over here seems to be another legitimate solution. Now that, of course, isn't going to help us solve the problem, but having that visualization of what exactly we're looking for might be quite helpful. So what does all of this mean? The tangent at the point is parallel to that. Well, that says the tangent, tangent gradient is 4. But we know that the derivative is telling us what the tangent gradient is at any point. So let's work out the derivative for our cubic. Bring down the power, reduce the power by 1 for each of those. Noticing that x is really a minus 1x, so it turns into minus 1. So we've been told that this, we're trying to find the points where this is equal to 4 to be parallel to y equals 4x minus 9. Well, this again is a quadratic, so let's solve it as such. I'm going to bring everything to one side. Now I could use quadratic formula on that, but I hate fractions, so I'm going to multiply by 5 to kill off the fractions, and then I like factorising, so I've already spotted the factorisation for this. Two numbers which multiply to 25 are 5 and 5. I can make a negative 15 from 3x times minus 5 plus the 5x from the 5 times x in the other sections. Of course, if your factorisation isn't as efficient, you're welcome to use a formula or split the middle or any other of your techniques. So we have our x coordinates of negative 5/3 or 5, and that's all the question wanted. We have two possible values for the x coordinates of the point P. If we look back at our picture, well, that doesn't seem too unreasonable, does it? We've got what looks like our solution of 5 here. We have some negative solution, just a bit bigger than negative 1 over there. That doesn't seem unreasonable, so I'm quite happy to say that question is sorted. Question 20, and our final question. Solve this. Well, this is quite a nice, well, it's actually, I like this question. We have a quadratic equation, but the quadratic is in terms of cos. So again, like quadratics, I'm going to rearrange everything onto the same side. And now this is what we call a hidden quadratic in cos. Does that factorise nicely? It must do, with a 2 in the middle and a 3 over here. Well, the only way to make the 1s is with a 1 and a 1. I want a positive 2 in the middle, so let's have a cos x plus 1 and a 3 cos x minus 1. If I were to expand that out, I get a 3 cos x and a minus cos x, which gives me the 2 in the middle, and that's happy. So therefore cos x equals, from the first bracket, a third or negative 1. Now at this point I'm going to do a quick sketch of the cos graph in the range needed between 0 and 360. Well, actually from this straight away I can work out what cos inverse of minus 1 is. Cos inverse of minus 1 is my 180. Of course your calculator will tell you that as well. And then cos x equals a third. I'm getting two solutions there. My principal solution from my calculator, cos inverse of 1/3, is 70.5, and there's more after that, but I'll put 70.5 for now. Now how do I get my other solution? Well, if we remember our tricks and our symmetry, if that bit there is 70.5, and that bit there is 70.5, so we can find that solution by 360 minus that value. So 360 minus answer gives me my other solution of 209.5. And I have pre-rounded those to 3 sig fig. That's your standard rounding level. So it turned out that there were 3 answers. I'll put them on the answer line, and we are done. Please do let me know if there are any problems with these. If you spotted any errors or any mistakes, I'll be very happy to hear from you. Otherwise, happy revising, and I'll see you soon.